Alright, so this is Enterprise mvvm session 5, and we're going to talk about dependency injection management with Unity and mocking with mock. So before we get started, if you need to grab the source code, make sure you grab that from session 4. And we're going to go through this deck of slides really quickly, no frills, just very couple of concepts I want to get across and set some objectives for the session. So the first thing I want to talk about real quick is dependency injection. And the first points I want to get across are, one, it's just a pattern. And I'm actually going to use what James Shore said is dependency injection really means giving an object its instance variables, because really that is what you're doing at the end of the day. So we have a code example, class T takes a T dependency as a constructor parameter. We assign that to the class's instance of that. And then ultimately the second line of code down here where we create a new instance of T and pass that in, that is ultimately the act of dependency injection. So it's a very simple pattern. It's not much more complicated than that. So the other thing that kind of goes hand in hand with talking about dependency injection is inversion of control. And at the end of the day, it's just a pattern and it's just a form of dependency injection. Now you have common forms of dependency injection like constructor and property injection, method injection, but you also have forms of it using things like service locators and factory patterns. So again, we have a very simple example of class T. It has the same dependency, and instead of passing that in using constructor injection, we are using the service locator pattern to resolve that dependency for us. And then ultimately, we can just create an instance of a new class of type T. So very basic concepts. Now our objective with session 5 is going to be a few basic things. Number one, we're going to mock the database dependency out that's in our main view model class. And we'll do that by extracting an interface and then mocking that out in our unit tests using mock, which is a unit testing framework. This will give us faster unit tests because we're not relying on the database dependencies. We won't be talking to SQL Server anymore. We won't be talking to Entity Framework anymore. They will just be pure unit tests in memory using a list of T. This will also give us less tight coupling between layers and components, so better separations of concerns. And it will give you a basic introduction to mocking and dependency injection management. And we're going to use Microsoft's Unity framework for the dependency injection management. And then ultimately out of all of this, what you'll get at the end of the day is how this all fits together into the mvvm pattern and our project. So like I said, no frill slides, so that's it. So we're going to go straight to the code at this point. Okay, so in Visual Studio, there's two steps we need to take before we can write any code. So we're going to go up here to Tools and NuGet Package Manager, and then the Package Manager console. And what we're going to do is install the two frameworks that we'll need, the first one being Unity and the second one being Mock. So you need to make sure that you have the Enterprise mvvm desktop client project selected, because that's where the Unity package needs to be installed. And the syntax is just install -package, and then the name that we're looking for in this case is just Unity. Then we're going to select our desktop client test library, and we're going to do the same thing, install -package and do mock. So once you have those two packages, we're ready to dig into the code. Now the first thing that we're going to do is go to our business context class and go ahead and extract the interface from it. So we're going to go ahead and do that, refactor extract interface. And we care really only about add new customer, update customer, and get customer list. We don't want data context, that's a dependency on Entity Framework, and then ultimately SQL Server. And we don't want to extract the dispose methods at this time. So we're going to do that. We're going to place that in its own file. And if you don't have the ReSharper one, the built-in Visual Studio extract interface should work correctly. And if you don't want to use that, you can just do it by hand. But ultimately, we're just creating a iBusiness context interface with those three methods. Now we are briefly going to add a new one called delete customer. And we're going to add that method to our business context for the time being. And we're really just going to throw a not implemented exception for now, and we'll come back to that later. And then the last thing we're going to do is refactor, rename this add new customer to create customer throughout the project to be a little bit more consistent with the naming of delete customer, update customer. And again, you can use a tool like ReSharper, or you can go and do that by hand throughout the program. Once you refactor that, you want to build the solution, make sure the refactoring changes all compile. Once you have that and it succeeds, you can move forward at this point. So we have our interface definition. Now, before we actually make any actual code changes in terms of functionality, we actually need to start from our unit test standpoint. So we're going to go to our main view model test file. And the first thing we need to do is we're going to introduce a test initialize method. So what's going to happen is this is going to run each time a unit test kicks off. And I'm going to use ReSharper to automatically import all the using statements for all the types. But ultimately, you're going to add a using statement to import the types from the mock namespace and system collections generic for our list of T. So what this code is kind of showing you is we're going to create a list of customers. We're going to call that store. Now, this is the actual object that is representative of our database. So instead of storing the records, adding and deleting and updating in SQL Server, we're just going to do it in a list in memory. And that's what allows the unit test to run so quickly without those dependencies. Now, the way we set this up is the syntax is using mock. You're going to create a new instance of mock with iBusinessContext, the interface we just extracted, as a type parameter. And that will create that object. Now, the definition of that, we're going to create one up here as a private member because we'll need that throughout our unit tests. We're just going to do mock, call it that way, and we'll need one more instance member, which is our actual list of customers. And actually, excuse me, our mock needs to be of iBusinessContext. So to kind of explain what this code is actually doing, we're setting up the mock object. So basically this is going to create a concrete type that implements the iBusinessContext interface. So we don't have to actually explicitly declare another class that derives from it and implements those methods. That's kind of one of the benefits of using a mocking framework like this. So with that said, though, that implementation is going to have zero default behavior. So we're going to basically set up all the functions that we care about, which really are the methods defined on this interface. So get customer list, we're going to say that that implementation that mock creates should just actually return to us all of the customer entities in this list of customers called store. So that's all that's saying. Now these next three lines, we're basically going to take these next three methods, create, delete, and update customer, that take a parameter of type customer, and it can be any parameter that's of type customer. We don't care what values it has set on it. It's just any customer object can be passed in. And we're just going to defer the functionality of that method call, which is what this callback syntax does. So whenever we call create customer, it's going to call this callback instead. And the work that we're doing is we're going to take that customer parameter passed in to create customer, and we're ultimately going to call store.add and then our customer instance, and the same thing for remove, and the same thing in the case of update. Now update's slightly different in the sense that we're going to go ahead and just replace the entire entity at the index of that customer object, which should match the primary key, and we're going to replace that with the new instance. So that will kind of, these four things mimic our most basic database functionality of creating, reading, updating, and deleting. So that really is all that's necessary in terms of actually mocking out the database. Now the next thing that we need to do is go through our unit testing code and indicate our new business requirements to utilize that new interface definition. And we need to be able to pass in through the pattern of dependency injection our mocked instance of that interface. So to do that, we're actually going to utilize our new mock instance member that we created, and the mock object will actually have a property called object which stores the instance that it creates of our iBusinessContext interface. So we're going to go through all of our unit tests and add this. So any constructors that you call for main-view-model, go ahead and do that and replace that by passing in mock.object throughout the entire file. And the other thing that you'll want to do is remove all concrete references to business context. So I'm going to cut the video here, do all of that, and then we come back, we'll just scroll through it real quickly and show you what you should have in your source file. Okay, so now that you've added all the constructor calls by passing in the mock.object as a constructor parameter, I'm sure you've noticed there's some unit tests now that don't make sense because there's still, even with removing all the references to entity framework and the concrete business context class, you're left with these calls to context.dataContext, which is ultimately the entity framework. And we had a couple unit tests where we would reload the values from the database to verify that they were updated. So with that said, these unit tests are actually going to go away completely, and it will all kind of make sense here in a minute when we dig into it a little more. So what we're going to do is actually this save command, selected customer's first name is updated in data store. That's going to go away. Same thing with the unit test that verifies the last name, and then same thing with email. So all three of those save tests go completely away, and they're ultimately going to be replaced with a new unit test, and we're going to call this save command invokes iBusinessContext update customer method. So we're going to change essentially our expectation from validating this information in the entity framework directly to just ensuring that our view model calls into our interface contract. My code snippet's a little off, so the service is actually going to be replaced with mock.object. Same thing here. So to kind of show you what this unit test is doing, it's ultimately the same as the previous save command unit test, except instead of asserting that the object was updated or added in the database, we're actually going to use the mocking framework to verify that our update customer method was in fact called by invoking our update command. And ultimately elsewhere in our unit test framework, there will be integration tests to make sure that the update customer concrete implementation does what it's supposed to do. So really what we have here is a separation of concerns where at this layer of the application, we're only concerned with verifying that we're calling into a known interface contract, versus in our actual data and business layers of the application, we'll verify at that point that the update customer method works correctly. And then the concrete implementation will be injected later using Unity framework. So what we're saying here is we want to verify that that update customer method gets called. It will take any type of customer, and we want to verify that it was called exactly one time. So we're going to add that unit test. Now the next unit test that we're going to go and clean up here is we have another one for this delete command. This will get removed as well, so we're going to replace this guy completely, and we're going to replace that with a new unit test called delete command invokes iBusinessContext delete customer method. So, and pretty much the same thing where we want to verify that we're calling into our contract method delete customer. So the signature looks identical, just a different name for the method. So we have a couple, actually that is all we need to clean up. So when you're done making all these refactoring changes, the only thing you should be left with in this main view model test file is all these compiler errors for the constructor parameter that's not supported right now. So it should be pretty clean. So once you get to this point, we're actually ready to make that functional change in the concrete implementation. So if we go to our data library at this point and we go to our, or excuse me, not our data library, if we go to our desktop client project and go into our main view model itself, remember that previously we had created two constructors. We had a default constructor which just created a new business context all on its own, and then we had this optional constructor that would take one as a parameter. So the functional change that we really can make with this is just add the I to that, so we're using the interface instead of the concrete implementation, and ultimately you need to update the private instance member as well. And what that will do is if you go back to your test file for main view model test, you can see that obviously now our tests are going to compile correctly, and that was really the only functional change we had to make in our code. So we're also going to go in here though and clean some other things up. We had a concrete reference to the business context down here in add customer, so we can completely get rid of that and just use our instance context, which is the interface, like so. It's a very simple change. And then down here in delete customer, you can remove these two lines of code with context delete customer and simplify that a little bit. So again, in your unit test file and now your actual main view model file, you should have 0 concrete references to business context and just 2 select references to iBusiness context. So we're going to leave this default constructor. This is actually the last reference to it, and we'll show you when that will get removed. But for the time being, we're going to go ahead and compile the project. And we're going to make sure that our unit tests run and pass at this point. And we're just going to run only the view model tests for now. And what you can see is by running those unit tests that now instead of executing in 500, 600 or more milliseconds, now most of our tests execute in 1 millisecond or to a well below 1 second each. So it runs almost instantaneously when we run this. So the last piece you can do in your test file is you can now remove this reference to the base class functional test, because that's no longer needed to set up and tear down the database. And we had overridden that anyway by declaring our own test initialize function, but you can just remove the reference. So at this point, you've successfully mocked out the database 100% in your unit tests for the view model class. Now, if we actually run the application code, we can see that it still works. But I want to show you a good example of why you still need some level of end-to-end testing. So while all of our unit tests work and we're verifying that our delete command is really the prime example that we're going to look at, invokes our interface delete method, if we actually try this through the user interface, we can see that we actually get an unhandled exception and it crashes our application. And that's because at runtime, we're using the concrete implementation of business context, whereas in our unit test, we're just using a mock. And if you remember correctly, we had added in our business context the delete customer function, and I actually had told you in the previous session to go out and write your own. So in my version of this, I have not implemented. So what we're going to do, so you can compare how you created your delete customer method with how I'm about to create mine. We're going to go into our data layer tests and go to customer scenarios, and down here we're going to add a new unit test for delete customer, and it's a simple unit test. We're just going to create a new instance of the context, add a new customer, delete it, and then make sure that there are no customers in the data context once that's called. So right now, if we were to run this integration test, we would see that it's going to fail because we haven't implemented that delete method yet. So we're going to go into our business context at this point. And really it's going to be as simple as taking the context and just removing the customer from it. And then saving the changes. So now if we rerun that unit test, we'll go ahead and do that through the Visual Studio test runner. So we'll compile the project, run it. Now we'll get a passing unit test because we've implemented the functionality. So now if we run the application, we'll refresh and delete that customer again, and it will be successful at this point. So it's very important that you have both unit testing, but you need, again, consider your end-to-end testing. And you're still testing not necessarily the same things. Our unit tests strictly test the behavior of the view model by itself. And we make sure that the view model does everything it's supposed to do. And our expectation for the view model is in fact calling into the interface definition. So by all means, our view model is fulfilling all of our requirements. And we still are covering or having good code coverage because we still are unit testing our actual concrete implementation as well. And these tests are ones, these 4 delete, add, update are what actually are hitting the database. So the very last change now that we've gone through that example is we're pretty much done with all the changes that, or we've actually fulfilled all of the objectives that we set out to accomplish. So the last thing that we want to do is introduce Unity's dependency injection management in the application. So this is going to look, if you've never used one before, it might look a little bit different to you. But we're going to go into the desktop client, into app.xaml, into the actually app.xaml.cs, where we had our initialization of the main window, and we're creating an instance of the data context, and then ultimately showing the dialog. We're going to remove all of this code and replace it with now this new code. And again, you'll have to add references to the Unity namespaces and your different interfaces and concrete types. But what this is doing is we're just creating a new instance of the Unity container. This is the class that manages your dependency injection for you. And we're going to register our interface and tell the container that anytime we ask for an instance of iBusiness context, I want you to give me back this specific concrete implementation of that interface. And then we're going to register our main view model. Now, how these two pieces play together is anytime I ask for main view model, which I'm going to do by saying container.resolve, and then I'm going to say go grab me an instance of main view model, because main view model's constructor takes an iBusiness context as a parameter, Unity will look at that and say, do I have an iBusiness context registered, and do I know anything about it? And if so, I know how to create it for you. So you can see here that we're asking for main view model, but we're not specifying an instance of the context. Unity is going to take care of that for us. So it's going to say, I'm going to give you a new main view model, and because it takes an iBusiness context, I know also how to create that, and I'm going to give you a business context in return and inject that using dependency injection into the constructor main view model, and then return that object back to you. So that's kind of one of the big benefits that it gives you. It simplifies code, and you can understand a scenario where you might have a lot of complex dependencies. You know, what if we had a view model that had 4 constructor parameters, and each of those constructor parameters had dependencies of their own? So maybe ultimately at the end of the day you had 20 total dependencies. That can be a lot of code to write out and set up just for creating a new instance of a main view model. So Unity removes all that code in place of a single line of code and a little bit of registration up front in your application. Now the very last piece that we can take care of now that we've used Unity to take care of our view model creation is now we can actually go into our main view model class, and if you have ReSharp or Visual Studio, you can do a find all references or find usages, and you could see that now we have no usages of the default constructor. So ultimately we can now remove the very last concrete reference to our business context. So our view model is completely independent of any hard dependency, whether it's a database or any other dependency that there might be, and it just only knows that it's going to communicate with this contract at the end of the day. So we'll stop there. We fulfilled all the objectives that we set out to do in this session. If you found the video useful, as always, make sure to like and share it, and make sure to grab the source code in the video description below, and we'll see you next time.